From your 4.2 practice, we're going to go over a couple of the questions. So we're going to look at number 4. And first I want you to think about what quadrant you're talking about. So it gives us some restrictions that theta has to be between pi and 3 pi over 2. And if we think about our unit circle, look at where that is. That's actually in the quadrant 3. So that is the quadrant where tangent is positive and it's reciprocal, but everything else is going to be negative. So that means tangent's going to be positive, but sine will be negative. So we're giving that the cosine is negative 8 over 17. So we're going to do like we did in our investigation, and we're going to plug in what we know. So we don't know sine, that's what we're looking for, but we know that cosine is negative 8 over 17, and we have to square it because this is squared right here, equals 1. Use your calculator, and you'll go ahead and simplify this negative 8 divided by 17 squared, and we end up with sine squared theta plus, and this will give us 64 over 289 equals 1. Now we're going to subtract the 64 over 289 from 1, so we end up with sine squared theta equals, and then we get 225 over 289. Now, this is squared again, and we just want to know what sine is. So if we take the square root of this, it gets rid of the square, and we have to square root each of these pieces, because remember, sine is a ratio, so we have to know what the top is and the bottom is because it makes a right triangle. So the square root of 225 is 15. So sine of theta is going to be 15 on top, and because we're taking the square root, it could be positive or negative, right? And then the square root of 289 is 17. Well, we know that sine has to be negative, so we know we're dealing with the negative version. So this is negative 15 over 17. Now we got to find tangent. So we have cosine and we have sine. So remember, tangent on our quotient identities, tangent of theta is the same thing as saying sine of theta divided by cosine of theta. So if we're going to find tangent, we know it's going to be positive, so that helps us know. We're looking for here, and our sine is given as negative 15 over 17 divided by negative 8 over 17. Now, we can use our strategies here. 15 over 17, keep, change, flip, multiply by the reciprocal, 17 over negative 8. The negatives cancel, which is great. The 17's cancel to 1, and we're left with 15 over 8, and it is positive. On the second page, questions 5 through 10, you were using the Pythagorean identity to simplify the expressions. More than one solution is possible, so I'm going to work this problem and then show you what you could have gotten. So we're going to do number 7. All right, so we're going to start with our whole piece that we're given, and we're going to have to get rid of some of these fractions. So if we think about what's happening here, these are being added, and when we add things like denominators, great, but these are not like. One's cosine and one's sine. So we need to go ahead and change those by multiplying or get common denominators. So we can multiply this whole top piece here and get common denominators by doing multiplying by cosine and by sine. So what we end up having here, if we multiply this whole thing, so cosine theta and sine theta, we're going to end up at the bottom with cosine theta, sine theta, because we're multiplying those. And we're going to end up on the top with cosine and sine squared theta. So we'll have sine squared theta plus cosine squared theta, and all over just the 1 over sine. All right, and the reason we do this is because we want to be able to simplify further these pieces. So if we look at just this top piece right here, sine squared theta plus cosine squared theta, and you use your trig identities, you know that this equals 1. All right, then we still have cosine theta, sine theta, all over 1 sine theta. So we've gotten it down a little bit. And now we're going to go ahead and set this up as multiplication. So this will be 1 over cosine theta sine theta times, and we'll do the reciprocal here, sine theta over 1. All right, so then we'll see what we can get rid of. Well, 1s and 1s go away, so it's just a 1. Sine theta and sine theta go away, so what we end up with is 1 over cosine theta. So that's one answer. But 1 over cosine theta can also be written as one of your reciprocal identities, which is the same thing as secant of theta. So those are your two possible answers. One's just more simplified than the other. Let's look at number 9. So I want you to take this expression here and write it as a monomial with a single trigonometric function. So we're going to use our reference sheet, and we're looking at what we have first for secant of theta. Well, another way to write secant of theta is 1 over cosine of theta. And then that's times cosine of theta, and then minus cosine squared of theta. Now, we want to go ahead and eliminate things that we can. So if we're thinking about this being multiplies, like over a 1, these actually cancel out. And this ends up being 1 minus cosine squared of theta. And if you look at your trig identity sheet and look and see what would that equal, and if you look at your Pythagorean identities and find the 1, and it could say cosine squared first, it could be manipulated around, so you got to think about what it equals. But 1 minus cosine squared theta is the same thing as sine squared theta. And that is your answer.